A separately excited DC generator supplies a current of 200 ampere at 125 volt to a load of constant resistance when driven at a speed of 1200 rpm. So it is given that when the generator is driven at 1200 rpm, it is supplying 200 ampere current at terminal voltage of 125 volt for a constant resistance. Next, calculate the current delivered when the speed is reduced to 1000 rpm. Now, the speed is reduced to 1000 rpm. He is asking us to calculate the current delivered. Armature resistance and brush contact drop are given. So, what is the way to approach this question? First, students observe the change in speed is given. In the first case, speed is 1200. In the second case, it is 1000. So, speed is changing. So, just think, what is the term in the DC machine that is related to change in speed? Is it torque? Wrong. Why? Because torque is related to change in current. Next, what is the other quantity? Yes, back EMF. Back EMF is related to change in speed. So, when the speed changes, our back EMF changes. EB is equal to Ka into phi into omega. Since it is a separately excited machine and the excitation is constant, Ka phi will be constant. EB will be directly proportional to N. So, what is the approach we should take? With the 1200 rpm, we should calculate our back EMF, and with 1000 rpm, we should again calculate our back EMF. With this back EMF, we should calculate our current. So this should be our approach. Let us solve. In the first case, I am drawing equivalent circuit. So this is our back EMF and this is brush contact drop. It always opposes the back EMF. After this, there is armature resistance 0.04 ohm, and after this, there is a load of constant resistance. It is delivering 200 ampere at the terminal voltage 125 volt. So here we should calculate the back EMF EB1. How to calculate? Just write the KVL here. From this, EB will be 2 plus 0.04 into 200 plus 125. So this is 2 plus 8 plus 125, which is 135 volt. Now we got our EB1. Next, what is the load resistance? RL is equal to 125 by 200, that is 0.625 ohm, and this is a constant value. So this is the first case. Next, now EB is reduced to 1000 rpm. So with these data, we should calculate our EB2. EB proportional to N. So EB1 by EB2 will be N1 by N2. From this, EB2 will be EB1 into N2 by N1. So EB2 will be 135 into what is N2? 1000 rpm. What is N1? 1200. This comes out to be 112.5. Now we calculated EB2. By using this EB2, we should calculate the current again. So here EB is 112.5. Now this is second case. From here, current IA will be IA is equal to 112.5 minus 2 by 0.04 plus 0.625 ohm. And the answer is 166.16 ampere. Is this clear? First we calculated the back EMF with the given data, and by using the relation EB proportional to N, we calculated EB2, and from this we calculated IA2. So this should be the approach for this kind of problems.